Hi Grade 10s, I'm John McBride.
And I'm Joyce Pogo. Today we'll measure the temperature of water as it melts and is heated to its boiling point. We'll also measure the temperature of water as it cools.
Using this data, we will plot graphs of temperature against time, first for ice heated until the water boils, and secondly for hot water cooling. These graphs are called the heating and cooling curves of water. In theory, if we heat ice at a constant rate, we should get a graph of temperature against time that looks like this one. The temperature of ice remains constant for the time it takes for the ice to melt. The temperature of boiling water remains constant while the water boils to form steam. And the temperature of water rises steadily from ice point to boiling point.
So, you can see that we need to measure temperature, time, and to record phase of water while we carry out this investigation. We will measure the temperature every minute and record the phase of water when we do this.
So let's take a look at the apparatus that we need for this investigation.
Okay, we need ice and a thermometer to start with. Here is the container of ice. We want to pack ice around the thermometer so that we measure the temperature of ice and not that of the air that surrounds the ice. The thermometer fits snugly in the ice. It's surrounded by the little chunks of ice just as we want it to be.
Remember that when we read the temperature using an alcohol thermometer like this one, we must read from the bottom of the meniscus.
The temperature of the crushed ice is 0 degrees Celsius.
So we have a thermometer and some ice, but we also need a heat source and something to record the time between the recording temperatures.
Yes, we will use a Bunsen burner, which we put underneath a tripod stand. We put a gauze mat on top of the tripod so that it spreads the heat evenly over the surface. And we place a beaker of crushed ice on top of the gauze mat.
We need to secure the thermometer in the beaker. The thermometer stays in the ice and water so that it constantly measures the temperature of the water. We don't need to take the thermometer out of the water at any stage of this investigation, so we're going to clamp it into position.
So here's the retort stand and a clamp to support the thermometer in the beaker. Push the thermometer through a one-hole cork or rubber stopper. Support the stopper in the retort stand clamp and immerse the thermometer in the beaker of crushed ice. Do make sure that the thermometer is a couple of centimeters above the bottom of the beaker. It must measure the temperature of water rather than the temperature of the flame.
Here is a diagram of the apparatus. You'll find the same diagram in your worksheet. It's time now to clearly identify the dependent and independent variables and the control variables in this investigation. Firstly, what is an independent variable?
It's the variable that we choose to change, the variable that we adjust before we take a measurement.
In this investigation, the independent variable is the time interval that we choose between recording the temperature of the water.
We are choosing a time of 1 minute between recording temperature and phases of water.
We will use a cell phone to take the time. I will warn Joyce to get ready just before the minute so that she has time to focus on the thermometer. Let's move on to the dependent variable.
The dependent variable is the variable that changes its values depending on the changes made to the independent variable.
The temperature of water depends on the amount of heat supplied by the Bunsen burner, and the amount of heat supplied by the burner increases with time.
So, the temperature of water depends on the amount of time the water is heated.
But phase of water is also a dependent variable. When ice is heated above 0 degrees Celsius, it melts. So the phase of water depends on the temperature and therefore in this case on the time for which the water has been heated.
But for all of this to be true, we need to control a few other variables.
Yes, the Bunsen burner flame must be adjusted to burn at a constant rate.
We must set the Bunsen burner to burn and to leave it that setting for the entire investigation.
We mustn't readjust the Bunsen burner flame at any stage during the investigation. The rate of heating is controlled.
The mass of water must remain constant. We start off with a certain amount of ice in the beaker, and we shouldn't add or lose any of the water during the investigation.
That makes sense. But what about the water that evaporates from the surface of the liquid as we're heating it up?
In this investigation, there will be a slight loss in mass of water as we heat it up. But we will not change the mass of the water ourselves while the investigation takes place. So, the mass of water is a control variable.
Right. Are you ready to start the investigation? Learners, you will need a couple of minutes to read through the worksheet. You will need a pencil, a pen, a ruler, and maybe an eraser. Pause the video while you read the worksheet and organize yourselves. This part of the investigation can take up to 40 minutes to complete. We're going to show you how it starts off, and then we will fast forward the results for you. Let's begin.
The apparatus is set up and ready. We start by measuring the temperature of the crushed ice before we begin heating it.
The temperature of the crushed ice is 0 degrees Celsius. This result is at time equals 0 minutes, and the phase of water is solid.
Fill these results into the table of your worksheet. We will help you with the first set of readings, but hereafter you need to pay attention to what we're doing and to record the results by yourself. Now we begin heating the water.
We set the Bunsen burner flame, place the burner under the tripod. At the same time, we start the timer on the cell phone. Now we wait for a minute to pass, but we keep observing what is happening to the ice, and we keep an eye on the timer so that we are ready for the next reading.
We can see that the ice is beginning to melt. The temperature is 0 degrees at 1 minute. The ice is melting. There are still big chunks of ice present. Just a little bit of it has melted already.
So what should we write down for the phase of water?
Perhaps it's best to write solid stroke liquid.
Now we wait for the rest of the minute.
The temperature is 0 degrees at 2 minutes. Most of the ice has melted. The phase is still liquid stroke solid. The temperature is 1.5 degrees Celsius at 3 minutes. The water is still solid stroke liquid.
Now we're going to speed up the video and just show you the temperature readings each time. If it goes too fast, you can always rewind the video, or you can pause between each of the set of readings. Are you guys ready?
At 4 minutes, the temperature is 2.5 degrees Celsius. The water is still solid stroke liquid. This is the thermometer reading at 5 minutes. Write it down for yourself, learners. This is what the beaker looks like at 5 minutes. This is the thermometer reading at 6 minutes. Write it down for yourself, learners. This is the thermometer reading at 7 minutes. Write it down yourself. This is what the beaker looked like at 7 minutes. This is the thermometer reading at 8 minutes. Write it down yourself. This is what the beaker looked like at 8 minutes. This is the thermometer reading at 9 minutes. Write it down yourself. This is what the beaker looked like at 9 minutes. This is the thermometer reading at 10 minutes. Write it down yourself. This is what the beaker looked like at 10 minutes. This is a thermometer reading at 11 minutes. Write it down yourself. This is what the beaker looked like at 11 minutes. This is a thermometer reading at 12 minutes. Write it down yourself. This is what the beaker looked like at 12 minutes. This is a thermometer reading at 13 minutes. Write it down yourself. This is what the beaker looked like at 13 minutes. This is a thermometer reading at 14 minutes. Write it down yourself. This is what the beaker looked like at 14 minutes. This is a thermometer reading at 15 minutes. Write it down yourself. This is what the beaker looked like at 15 minutes. This is a thermometer reading at 16 minutes. Write it down yourself. This is what the beaker looked like at 16 minutes. This is a thermometer reading at 17 minutes. Write it down yourself. This is what the beaker looked like at 17 minutes. This is a thermometer reading at 18 minutes. Write it down yourself. This is what the beaker looked like at 18 minutes. This is a thermometer reading at 19 minutes. Write it down yourself. This is what the beaker looked like at 19 minutes. This is a thermometer reading at 20 minutes. Write it down yourself. This is what the beaker looked like at 20 minutes. This is a thermometer reading at 21 minutes. Write it down yourself. This is what the beaker looked like at 21 minutes. This is a thermometer reading at 22 minutes. Write it down yourself. This is what the beaker looked like at 22 minutes. This is a thermometer reading at 23 minutes. Write it down yourself. This is what the beaker looked like at 23 minutes. This is a thermometer reading at 24 minutes. Write it down yourself. This is what the beaker looked like at 24 minutes. This is a thermometer reading at 25 minutes. Write it down yourself. This is what the beaker looked like at 25 minutes. This is a thermometer reading at 26 minutes. Write it down yourself. This is what the beaker looked like at 26 minutes. This is a thermometer reading at 27 minutes. Write it down yourself. This is what the beaker looked like at 27 minutes. This is a thermometer reading at 28 minutes. Write it down yourself. This is what the beaker looked like at 28 minutes. This is a thermometer reading at 29 minutes. Write it down yourself. This is what the beaker looked like at 29 minutes. This is a thermometer reading at 30 minutes. Write it down yourself. This is what the beaker looked like at 30 minutes. This is a thermometer reading at 31 minutes. Write it down yourself. This is what the beaker looked like at 31 minutes. This is a thermometer reading at 32 minutes. Write it down yourself. This is what the beaker looked like at 32 minutes. This is a thermometer reading at 33 minutes. Write it down yourself. This is what the beaker looked like at 33 minutes. This is a thermometer reading at 34 minutes. Write it down yourself. This is what the beaker looked like at 34 minutes. This is a thermometer reading at 35 minutes. Write it down yourself. This is what the beaker looked like at 35 minutes.
That's fantastic. We have enough information to plot a graph of the heating curve of water. Learners, before you leave this table of results, have you given your table of results an appropriate heading? Don't forget to do that. Also check through your table of results and make sure that all your readings have the same number of decimal values. If one reading is 0,5 or 7,5 and all the other readings have no decimal values, then you need to write them all to the accuracy of the same decimal place. Finally, the SI units are shown in the column headings. Don't write the SI units in every row as well.
This is the correct way to record your result in a table. It's nice, neat and clear. It makes it easier to work with the information when you analyze it.
Some of you may have made a few mistakes in your table and perhaps you want to correct them nice and neatly. We have printed another table exactly for this purpose. You can transfer your results later and make a clean start. Now we're moving on to the cooling curve of hot water.
The hot water has to cool down. It can cool down in the air, but the rate of cooling will be fairly slow. We have decided to cool the hot water in a trough of crushed ice so that it cools at a faster rate.
So let's pick up the beaker of hot water and we're going to put it into the ice. There we go. And we must then be careful that we don't lose any of the crushed ice either, or the hot water. Now the next thing is we're going to put the thermometer into the hot water so that we can see what happens. We're supporting it with the clamp and the retort stand to make sure we're measuring the temperature of the hot water. Take a reading on the thermometer and start the timer to measure 1 minute intervals.
The temperature is 45.5 degrees Celsius at 0 minutes.
We don't have to worry about a phase change during the investigation, as the water will never be cold enough to form ice unless we use a fridge or a deep freeze to cool it. Get ready for the readings at 1 minute.
At 1 minute, the temperature is 35 degrees Celsius. Right, are you ready for the fast forward readings? Here we go. 2 minutes. 3 minutes. 4 minutes. 5 minutes. 6 minutes. All done. If you missed a couple of values, you can ask for the video to be replayed, and you can pause it at the individual values. However, don't take too long doing that. There's plenty more work for you before you complete this practical investigation.
It's time now for you to work individually and to complete the graphs and answer the questions that follow. Where necessary, ask your teacher for support. Don't ask your neighbor or other learners in the class. This is an assignment which you need to complete by yourself with expert guidance from your teacher if necessary.